Let's look at a second question. On this question, I'm going to find the speed right before the F1 stopping force. So it's where the blue circle is located. To do this, just like before, I'm going to use conservation of any energy methods. I don't need time, and I'm comparing two locations. So I have a choice for my second location. My first location comes from the question. Find the speed right before the F1 stopping force. So that's the blue circle. Now in my other location, I have two choices just like before. I need a spot where I have the height and the velocity. At 65 meters, I don't know the velocity, so that's not a choice. So instead, I'm going to use 52 meters and 18 meters per second as my second choice for comparison. So I'll set my total energy at the top of the ride equal to total energy at the bottom of the ride. No other forces act between these two locations, so I don't need to worry about the work. So I'll set it up as kinetic plus potential equals kinetic plus potential, and then I'll go through my questions. At the top of the ride, is it moving? Yes, it's moving at 18 meters per second. At the top of the ride, is it above the lowest height? Yes, it's the top of the ride. At the bottom of the ride, is it moving? We think so. Generally, when things go down the hill, they pick up some speed. And at the bottom of the ride, is it above the lowest height? No, it is not. So I'm going to get rid of that potential energy in my formula. Now I throw in the numbers that I know, the formulas that I know. So 1 half mv squared plus mgh equals 1 half mv squared. And I'll divide out the m's because there's an m in every piece of the formula. This will simplify my formula to 1 half v squared plus gh equals 1 half v squared. Remember, even though the v squares look like they're the same, the one on the left has all the values from the top of the ride, and the 1 half v squared on the right has all the values on the bottom of the ride, and they're different. Now I'll throw in my numbers. 1 half 18 meters per second squared plus 9.80 meters per second squared times 52 meters equals 1 half v squared. At this point, I can solve for the velocity. And if you solve for the velocity, you'll get this for an answer: 32 meters per second.